Hello and welcome everyone to today's LeetCode challenge. This is our day 297, and today's LeetCode question is maximum ascending subarray sum, question number 1800. In this question, we have given that we given an array of positive integers called nums, and we have to return the maximum possible sum of an ascending subarray in nums. Subarray is basically defined as the contiguous elements in an array, and an ascending subarray basically means that every adjacent next element is greater than to its previous elements. Let us take the example number 1, in which we have given 6 elements: 10, 20, 30, 5, 10, and 50. In this we can find out that the maximum possible ascending subarray is 65, which is from this 5, 10, and 50. And the other subarray possibles are this 10, 20, 35, 10, and 50. Each of them is a subarray, and each of them singly is an ascending subarray, because every single element in itself is a subarray of element, and it is increasing as well because there are no previous elements to compare. And we can find out that two length subarray are this 10, 20, 20, 30, 30, 50, but this is not an increasing subarray, so we cannot include this as our answer. And this 5, 10, and 10, 50, these are two length subarrays, but basically we can have the three length subarrays from this, which have the maximum sum greater than this two length subarrays. So we will find out that three length subarrays, and one of the three length ascending subarray in this is 10, 20, and 30, which adds up to 60. And the another three length subarray in this is this 5, 10, 50, which adds up to 65, and this is the maximum possible sum in this given input, which is the ascending as well. So we have to return 65. So let us just find out what will be the code for this, and let us visualize that code as well. So we have written our code for this, and this is example number 1. The code basically states that we have to initialize our temp sum, which points to num0, and a maximum sum which is initially initialized with 0. And why that num sum contains num0 is basically because of the fact that every element in itself is an increasing sub array of the input array as well. And we find out that nums of length is at least 1 as well. So this nums of 0 will never give an compiler error as well, because at least there is one element in num itself. So num0 contains this time 10, and maximum sum contains initially 0, and then we will start our loop from r equals to 1, that is this position, I equals to 1 till I is less than its size. That means from this index till this index, I will go till this last index. Let us take another color for this. I will start from here, and this will check if I, that is 1, is less than its num size, that is 6. If 1 is less than 6, yes, it is a true condition. So this for loop will execute, and this will find check that if this nums of I is greater than to its previous element, that is this 20 is greater than to this 10. Yes, it is a true condition, so our temp sum is updated to temp sum plus nums of this index as well. So temp sum is now 10 plus this 20, that is 30. So temp sum is now 30, and this else will not executed, so our I is now incremented. So let us erase this, and I is now points to here, and this will again check if this nums of I, that is 30, is greater than to its previous, that is 20. Yes, 30 is greater than to 20, so temp sum is now again updated to temp sum plus nums of I, that is 30 plus this 30, that means 60. Temp sum is now 60, and our I is again incremented, so I will point to this value now. So let us erase the previous pointers of I, and now again this at this index, the this if condition will again check that is this 5 is greater than to its previous, that is 30. No, this time the condition this if gets false, so this else will execute it this time, and this else will update our maximum sum to max sum and temp sum. So we will check what is the maximum of 0 and 60. Maximum of 0 and 60, and this will return as 60 as answer. So this time maximum sum will update it to 60. So maximum sum is 60 now, and our temp sum is now equals to nums of I, that means 5. So update our temp sum and maximum. So our temp sum is now this 5, and maximum is now 60, and I will again increment it, so I will go to this index and again check if this nums of I is greater than to its previous here. So we found out that this is true, that this 10 is greater than to its previous element, and if condition is true now, so our temp sum is updated to its previous value plus this current value, that is 5 plus 10, that means 15, and our I is again incremented and goes to the next index, that means this. So let us erase the previous pointers of I. Now again this will check if nums of I, that is this 50, is greater than to its previous, that is this. Is this true or not? Yes, it is true. So temp sum is now updated to 15 plus this previous value, 15 plus this current value of nums I, that is 50. 50 plus 15, that is this temp sum is now updated to 65. that means this. And again, when I is incremented, I will points to an invalid location here, and this for loop will now terminates because I goes out of the bound of this num size. So this for loop will end, and this return statement is now executed. That means this will return maximum of temp sum, and this maximum sum, the current value of maximum sum, and maximum of this temp sum and maximum sum is maximum of 65 and 60. So this will return 65 as the answer. This will return 65 as answer to caller. That means 65 is the answer for this first input. And here it is, the answer for first input is 65, and we can similarly check for this as well. And for this second, example, we can check that first I will points to this 10 here. Temp sum, initially temp sum contains the value of nums of 0, that means 10. So temp sum is initialized with 10 here, 10, and maximum is currently 0, so maximum is 0. I is starts from index 1, so I will starts from this, and this will check that if this nums of I, that is 20, is greater than to its previous value, that is 10. Yes, it is true, that is 20 is greater than 10. So temp sum is updated to 10 plus 20, that is 30. I is again incremented, so I will now goes to this index and check if this nums of I, that means 30, is greater than to its previous value. Yes, 30 is greater than 20, so this nums of temp sum is added to nums of R is added to temp sum, that means 30 plus 30, this is 60 now. Again I is incremented and goes to this index. Again the if condition is true and temp sum is again incremented by nums of R, that means 100. 60 plus 40 is 100, and I is goes to this last index, and the if condition is again gets true, and this temp sum is again 100 plus 50, that means 150, and this for loop will now terminates because I will go out of bound of index of num size. So finally we have to return the maximum of temp sum and maximum, that is maximum of this 150 and 0, that means we will return 150 as the answer for second input. So this will return 150 to the caller, and we can find out that this is num50. So now let us code our logic and check if it is 100% correct or not. Let us first take the size of input array and take nums of 0 value in temp sum and initialize our maximum to 0. We will go from one index to less than n, and check if this nums of I is greater than to its previous index I minus 1. If this condition is true, then we have to update our temp sum to temp sum plus nums of I, and if it is not true, then we have to update our maximum sum first, and then we will store the current nums of I value to temp sum. This, and finally when this for loop will terminates, we have to return the maximum of temp sum and max sum. Let us check if it is running fine or not. We forget to add p here. It is running fine. Let us submit this and find out if this is correct or not. And yes, it is correct, and this will beat 100% almost in memory and space complexity. So this will conclude our day 298, and thank you so much guys for seeing this video. And if you do understand this and do like this, so please like and subscribe to our channel. Thank you.